Hey all, it's Matt with Western Mold again, and today I want to talk about workholding integration. The integration of your workholding onto your equipment is kind of the low-hanging fruit of the automation process, but surprisingly, it's overlooked by a lot of machinery sellers who are eager to put equipment on your floor and even sell you add-ons, but they're not always equipped to help you solve your integration problems and really get work on your machine itself. Obviously, our goal is to provide these products for you off the shelf so that you don't have to make them. But in the meantime, I'm hoping that by walking you through some of the machines that we've automated on our shop floor, I can help evaluate and point out some of the pitfalls and shortcuts to making this a success. Before I dive in, I just want to give a couple disclaimers. Number one, all the fusion models that I'll be working with today are working models, so they have a lot of components in them that are not necessarily central to this conversation. So if you see me turning things on and off, but not diving into what they are, just know that they're probably related to a job or a product or something that was never installed. And then secondly, we work exclusively with Shunk Work Holding at this point. So if you're using another brand, whether it's Fifth Axis or SMW, just know that the same principles typically apply. Work holding manufacturers are usually pretty good about providing models, drawings, and any other data that you need to find the ports to actuate your work holding products. So having said that, let's dive in. The first machine I want to talk about is our DNM 4500S from Doosan, now DN Solutions. It's basically just your run-of-the-mill three-axis machine with 3+2 capability. And because we knew that we wanted to do five-sided machining, we bought it with the Lindex rotary from our local machinery seller. And we also bought the off-the-shelf rotary union from Lindex because that is something they offer. And I think that was about 1,200 bucks. So I'll just kind of walk you through how that installs because it comes as a separate item, the rotary joint, and Lindex doesn't install it for you. So if we hide the machine here, what you'll see is the model from Lindex does not come with a lot of detail, but there is a bolt pattern back here. And so the rotary joint comes with a spindle that slips. It's a precision fit through the center of the platter, which is nice because it makes this boss essentially into a locating boss for your work holding adapter, whatever you want to put on top of the platter. Once you slip the spindle through, there's a rotary nut that goes on the backside with your four media inlets slash outlets. And then the rotary nut is held in place by like a little finger that what you can't see here is that this actually has a static portion around the outside and a revolving portion around the inside. And so the static portion has a couple of bolt holes. You bolt the finger on, the finger interfaces with the rotary nut, holds it static, and then you got four air lines coming off the bottom of the rotary nut to a little manifold block that bolts to this base casting. And then from the manifold block, the kit also comes with a bunch of pre-cut hoses with some shields and some like retractable hanging cables that bolt to the top of the machine enclosure so that any extra slack that hangs here as your indexes left and right is kind of kept from getting caught under the machine or sucked into the chip conveyor. And those airlines, four of them, go up to basically some little nipples that are in the top of this white sheet metal here, not depicted in the model. But that's all you get from the manufacturer. So from there, it's up to you kind of how you want to actuate it. We knew we wanted to do manual actuation initially, and that's worked really well for us. So what we ended up using was this foot operated switch that we found on McMaster. And it's important that you buy the right switch with the right flow pattern because it not just any switch will work. So this 5-2 flow pattern, essentially the way it works is it allows basically it allows one to flow while it allows the other one to vent when you press the switch. And then when you release the switch, they swap. The other one flows and the opposite one vents. And the reason that's important is because a lot of these pallet systems have a turbo function. Basically, they're air unclamp, spring clamp. But if you plumb the turbo function to the unclamp position of, or to, excuse me, to the up position of your foot switch, then when you release the pedal, it actually brings in that turbo air, which introduces extra air to the backside of the platter, and it increases your clamping pressure, increases your rigidity, reduces the chances of a pullout, improves your finishes, all that good stuff. So using this switch or something with a 5-2 flow pattern is important. So once you've run the plumbing up to the sheet metal, you can put a little manifold up here with a pressure reducer. You can bring in ambient shop air from the back, and this is what we've done. So you've got a couple air lines coming off your rotary, air coming from the back, pressure reducer, which allows you to really dial in your pressures. We use these air vices quite a bit from Shunk, and so by specifying pressures in our setup sheets, it allows the operator during setup to climb up there with a step ladder, adjust the pressure reducer to the required pressure. And because we've used either engineering calcs or pressure gauges to know exactly what force we're getting, it is as though we've used a torque wrench on an old school CNC vise to set the clamping force for our part. And then from your manifold, you run a couple flex tube lines down to your foot switch, sits here on the floor, and it works great. We've run this for thousands of hours, tens of thousands of parts. Now, if you want to go fully automated with an M code and be prepared to integrate with a robot cell, you can do that. We've elected not to do that yet, but we plan to down the road. The nice thing about the foot switch is there's nothing stopping you from automating in the future. So you take the system that you've already developed, you disconnect the foot switch, you run your two airlines back to the side of your electrical cabinet, and you install your solenoids, which your CNC manufacturer can help you spec out, and they are equipped to make those solenoids interface with the machine control. That's pretty much it for this machine. The next machine I want to talk about is our Mazak VC500 5AX. And this is a great machine to highlight because, first of all, it is a full 5-axis milling center. So there are some new challenges associated with this one. But additionally, there was no solution provided for us by the manufacturer. So we did this one entirely from scratch on our own. And so I'll be able to walk you through that. It is worth noting that Mazak does offer a rotary joint kit. You can buy it from the factory. I think it's a $13,000 upgrade, and it is actually field installable. So they quoted it for us at about 13 grand when we bought this machine, and they offered us, I believe it was a 16 to 20 week lead time. So we ordered it, and while we waited, we worked up the solution that I'm about to show you. And what ended up happening was, first of all, this worked so well, we didn't feel like we needed the upgraded solution. We didn't need to spend the 13 grand. But also, after 20 weeks went by and we had heard nothing from Mazak, we reached out and there was no estimated completion date. Now, I'm not, this isn't a knock on Mazak. They're great machines, but they know where their priorities are. They want to ship new equipment. They're not necessarily as motivated to send someone like me an aftermarket option that wasn't initially equipped on the machine. So make of that what you will, but it is worth knowing that if you're purchasing a new Mazak and there is a provision for automation prep, I would highly encourage you to invest a couple extra bucks to provision it that way, because it'll save yourself quite a bit of heartache. Having said that, the machine as we received it was not provisioned with air through the trunnion. Now, I don't want to get too into the weeds with this, but if you look at the actual machine, if you roll the table all the way up on its side, you'll see that underneath the trunnion there is a, let me see if I can turn this off. I don't think it'll show up in this model, and this is not accurate either. But up inside the trunnion, there is a panel here, and if you remove that panel, there is a pathway through the back of the casting and into the machine enclosure, where presumably the manufacturer would route hoses. We didn't go that route because we weren't really interested in tearing into the guts of this machine and causing ourselves more trouble. So what we ended up doing, um, first of all, we needed to have a more accurate model of the trunnion. So we did a little bit of reverse engineering, um, not fully, but we got a little closer to the real deal, some important diameters, a bolt circle that we plan to use, and I'll walk you through that later. But we also had to stop and identify what rotary joint we were going to use. Now, this is a low RPM application, right? This is not going to do any turning. It's not a turning mill. So it's only ever going to index about the rotary, about the platter. So we're talking a couple hundred RPM at most for intermittent movements. So because of that, we were able to find a fairly simple consumer grade rotary joint from DSTI. And I think these guys go for $300-400, and they are on the shelf ready to buy. Super straightforward. Obviously, pressure's not an issue. Sorry, here we go. Pressure's not an issue, speed's not an issue. And suitable media, we're using air for everything. So we ordered this, and then we knew we had to get air from the backside of the platter up through the trunnion and into the table. So what we ended up doing was we ended up sinking the rotary joint all the way down into the hole through the platter. Because the diameter was large enough, this wasn't an issue. So what we did was we fabricated this base plate from scratch, piece of steel, tool steel, or if you want to go crazy, you can get something hardened, but it's not necessary. This is a precision slip fit, and it's worth noting at this point, and this is really important, we did remove the factory table, and this bought us like 2 full inches in the z-axis. So if you're planning to integrate and you know that you're going to run automated work holding forever, I highly encourage you to take a gamble and remove the existing platter, because many of these machines are not going to have exposed bearings underneath the table. They're going to have some kind of pocket like this. And there's no reason not to gain yourself a couple inches of Z, some rigidity, and ultimately Z turns into X, right? When you turn this thing on its side. So this machine is actually more X limited than it is Z limited. So by slamming the part as low as we could, we got closer to the center of rotation, but we also kept our taller parts away from the left-hand limit of the machine when it's fully indexed in the B axis. So yeah, we made the base plate, and this is the challenging part of this project. I know that might sound crazy. Hang on, I gotta turn some stuff off here real quick. You go away. And all right. I know that might sound crazy, and if you're used to deep hole drilling, gun drilling in your shop, then pay this no heed. But for us, these long cross holes to get air from these ports where our rotary joint had like a flush interface with O-rings out to the holes that actuate and vent our shunk pallet bases was a huge amount of work. But basically what we ended up doing was buying some gun drills off of McMaster. Obviously you have to pre-start the gun drilled holes. And I think our deepest hole here was, I don't know, 8 or 9 inches. But yeah, pre-start them with a nice carbide drill, mill yourself a flat if it's on a round surface, go in with the gun drill, obviously with the drill off, and then follow manufacturer's specs for the drilling process. But the cross drilling was the tricky part. But we fabricated this base from scratch, and it allowed us to put 2 shunk pallet modules, which really makes this machine more flexible because it does have a 24-inch max part diameter. And so we wanted that rigidity that came with the 2 pallets, and that's allowed us to run all kinds of different projects on this machine. So at that point, we had the rotary joint up inside the machine. but no plumbing coming down. So then what we did was we took this bolt pattern because this was the only static bolt pattern on the back of the machine that we could find. And these are massive, like M10, M12 threaded holes. But we just made a very simple mount plate, nothing special, and bolted it, piece of aluminum, bolted it to the back of the platter, and then the rotary joint, we had a couple of stainless steel nipples coming off the bottom of it that protrude just barely through this plate, and we put 90-degree elbows with quick couplings and then flex hose, and we took that directly to the right with very little extra slack so that when the machine is tilted all the way to the left, the hose doesn't even touch the sheet metal enclosure. There's no issues of like chips or uh, chip conveyor or anything like that. And then we just drilled 2 holes in the side of this panel, and we brought our air out through there down to our pedal, and then brought ambient air in from the back. And we use this exact same foot switch from McMaster. So all told, this project probably took us 2 days. Um, $600 or $800 worth of parts and hardware. Very simple, very painless. And again, this is run for 3-4 years, many thousands of parts. So this is a great solution. And again, same as on the D&M, if we wanted to fully automate this, we could either take our existing plumbing, it wouldn't be the prettiest thing, but run air along the sheet metal back into the enclosure and into the electrical cabinet, and then work with Mazak to interface with solenoids. Or we could go ahead and take the leap, maybe get a Mazak tech out here, tear into the panel on the bottom side of the trunnion, and route our air hoses through the back of the machine. But this approach of doing it all yourself is surprisingly doable for most machines. Manufacturers, all the manufacturers I've worked with do a really good job of providing models and drawings. To get more detail about the backside of this table, we found the pages in the manual that specify kind of what the back looks like. So we didn't have to do as much hand measuring. But this is that panel I was telling you about that would give you access through the trunnion into the back of the machine if you wanted to go that route. So yeah, that's how we automated our Mazak, and that's it for this machine. The next machine I want to talk about are these Brother M series multitasking machines. This is not a machine we have on our floor. This is actually an ongoing collaboration with Brother to try to provide some integration to make this machine more appealing for various customers. But the reason I really want to present this to you is because this is a mill turn. And so we are dealing with higher RPM. The smaller size, the 200 goes up to 2000 RPM. The 300 goes up to 1500 RPM. And so while it does introduce another layer of cost and complexity, it's still nothing that's going to keep you from doing this yourself if you have one of these machines and you want to automate. So much like Mazak, there is an automation solution available. It's $12,000, and it's not really set up for the kind of work holding that most U.S. customers want to do. It's air and oil. I think it has 1 air passage and 3 oil. And there's some other limitations associated with it, but it wasn't ideal for customers who are running shunt, fifth axis, SMW. Most US customers are not automating with hydraulics through the platter. So we really wanted to be able to provide a new solution. So here is kind of what we've been working through with Brother in order to put shunt on people's machines. So if I strip away some of the layers of the machine, you'll see I've got a lot more detail built out on this than on the previous machines because this is an actual live proposal. But the strategy is very similar. We've already gotten the layout of the plumbing from the current off-the-shelf rotary joint kit. And we felt that was important because we didn't want people to have to change their adapters if they were switching either to our product from the old kit or vice versa. We wanted everything to be interchangeable. So we were able to pull from the Brother literature the pattern of these tubes and even the height that they rise to and what their diameter is and all that good stuff. And we were able to recreate the exact same thing with these steel risers, but using a rotary joint that we had spec'd out ourselves. So we ended up going with a company called Dublin, and it was very difficult to find a rotary joint that would do this. 2000 RPM sustained with 4 passages of air. And we went with 4 again because it matches the current kit. So we felt like it was a superior offering. Additionally, if you want to do more than just clamp unclamp on one pallet or one vise with this machine, you can do that with 4 channels. You can clamp unclamp, you can do air sensing, clamp seat conformation, or you can even clamp top tooling and then pass air through a pallet to a vise. So you can actually have 2 different clamp unclamps with foot switches or with associated M codes. Kind of the sky's the limit. And because all of these are plumbed, and I'll show you in a minute how that's done, but they're plumbed to the back of the machine, that kind of makes it infinitely configurable because all of your adjustment, if you decide, hey, I want to make this one a foot switch and this one an M code, you just have to come back here and replumb these 4 lines without really getting your hands dirty. So the rotary joint from Dublin is about $3,800, $4,000. The lead time was like 8 to 12 weeks, nothing too crazy. The rotary joint will probably get to you before your machine does. Um, and these are German made. They are rated for up to 3 or 4,000 RPM, and they do, definitely exceed the pressure requirements for any shop running compressed air. But then after you get your rotary joint, there is some fabrication involved. Let me see if I can turn on a cutaway view here. So the rotary joint comes with this faceplate. You have to fabricate this spindle here, which is not as complicated as it seems, but it does interface with the precision bore of the machine, and it does interface with these riser tubes. Now, if you did this yourself, you would not have to do all of this finagling. If I were doing this for myself and not to match a current spec, what I would probably do is this spindle, because steel is cheap, I probably would just continue this spindle all the way up, have it end flush with the table, and install a couple O-rings on the holes coming out of it. Um, that would be much simpler than having to fabricate these 4 steel tubes, get all the fits right, find all the O-rings. But it really is just a flange with a boss in the middle and 4 holes. So once you've got your spindle, which with the adapter flange and your rotary joint on the floor, then the only other fabrication here is some kind of bracket that bolts up under the edge of the machine platter. The machine does come provisioned with these 4, I want to say they're M6 holes, and we plan to just bend sheet metal. You can do it however you want. We also went with quick couplings here so that maintenance would be easy, cleaning would be easy, troubleshooting would be easy. And we went with all high quality abrasion resistant rubber hosing from a local pneumatic supplier and all bronze fittings, brass fittings, excuse me. You can do this however you want. If you just wanted to use push to connect hosing and you didn't want to make the bracket, you just wanted to run it through the trunnion, wrap it in some abrasion sleeve, and bolt it to the side of your machine, you could do that. And it would probably run for thousands of hours that way. And if you pop an airline, hopefully you don't throw apart, but you can go this route, kind of fully built, high quality, or you can go kind of turnkey MacGyver style. And then after that, it does have a vent, not really necessary, but it's part of the rotary union. So we went ahead and plumbed it just to be safe. And then we found these little brackets on McMaster. They're nothing special, just pieces of plastic, sheet metal screws into the machine enclosure. And then the machine does have a, where'd you go? I think I just lost my machine in the mess. Yeah, the machine does have a trough here that's designed for these hoses. So this is how it would be run if you bought the OEM kit. And then again, another fabricated bracket. You don't have to do it this way. If you like dangling hoses, more power to you. Duct tape, whatever. But at the end of the day, now you can choose whichever two you want to use for clamp unclamp. You can plumb your foot switch the same way we have been back under the machine enclosure and go to town. Or if you want to automate, this machine has spare buttons on the control, lots of spare M codes. You could integrate all four of these into the machine, and then I'm sure you could talk with your local machinery seller about kind of custom mapping these so that you could change a few parameters, change a few settings, and maybe make two of these be clamp verification, part seat confirmation, or make it be a second clamp unclamp for tooling that is like air pass through on top of a pallet. But this is a really cool project. There's a lot of machines out there like this where either there's no solution or there is a solution, but it's not great, and someone needs to build one, which is something that we're hoping to do in the future. But hopefully you guys find this helpful. And that's it for the brother. Well, I would be remiss if at some point during this video I didn't talk about HAAS. I don't think you guys need me to hate on HAAS. There's plenty of people out there doing that already. The truth is, if you're a budget shop or a startup, or if you're doing light duty work, HAAS is great. They make good stuff. A lot of their stuff is still US made. Their support's good. Their integration is phenomenal. Their tooling line, I know they're actually buying a lot of quality brands. Some of it's cheap, some of it's nice, kind of hit or miss. I've heard stories about spindles falling out of HAASes, UMC 500s, but I've also heard stories about people running HAASes for 30 years. We have a VF2 on our floor that we bought in the mid 90s, and every couple of years something fails, we replace it, and it's still kind of our mold and die shop workhorse. So I'm not going to hate on HAAS. They make a lot of good stuff. But here's the interesting thing. HAAS does have their own 0 point and pneumatic vise system, and it looks like pretty cool stuff. It's not anything like Shunk or SMW, Fifth Axis, Lindex, any of the other big work holding companies out there, but it's a 0 point. It's cheap. It's decent. It looks nice. However, their integration and their offering and their support is extremely limited. So if you have a HAAS rotary or a HAAS UMC and you want to automate, you still may have to do it yourself. I guess the exception would be if you buy a newer UMC. A lot of those are already plumbed for automation. Or this one rotary size. If you have a TRT 210, you are in luck because this, for whatever reason, is the magical size that HAAS has deemed worthy of their 0 point system. And as you can see, they've got it all specced out here, air clamping provisions. You buy the kit, you you plug some stuff in, you do some magic, and voila, you have air clamping through the spindle. So for those of you who have TRT 210s, great, no problem. But if you have any of the other HAAS rotary options on any of your machines, and I think most shops have a HAAS rotary or more, um, you really aren't going to see that much support directly from HAAS. But it can be done, and it can be done very easily. So obviously, the fourth axis rotaries are the easiest because you don't have a trunnion to battle with. They are not provisioned for it in any way that I can clearly discern, but we've done this. We actually have a HRT 310 on our VF4 that I plumbed for air, and I put a shunt pallet on the face. I actually removed the faceplate, made my own, again, trying to save space and rigidity, but and we plumbed it for air. We put a shunt platter right on the front, and we've run all kinds of parts on that thing. So it's a very easy process. If you don't want to discard your OEM platter, that's no problem. All you have to do is make some kind of adapter that will interface with this precision bore. And of course, the bore diameter is going to change for each rotary size. And then use T-slots to bolt it in place, get it all dialed in, and then install your work holding on the nose. Um, this may not be ideal for everybody, but if you want to reach four sides of your part and you're willing to palletize, going with a shunt Vero S or something similar on the side of a rotary can give you tons of access to your parts. Or if you have something long and you can hang it between a pallet and a steady rest, or if you have a little tombstone, right? All the kinds of things you can think of can be done with air through a rotary. So the process is simple. Once you've made your adapter with the air provisions and the holes in the back, you buy that same $200, $300, $400 DSTI rotary joint that I referenced earlier, talking about the DNM, and I'll put that link in the description here. But you install that thing in the back. You need to obviously give yourself some risers or nipples coming through the platter if the rotary union won't fit down inside the hole. The other thing that's worth noting is that these rotary joints, the plumbing, the incoming plumbing is on the outside of the rotary joint body. And so if you're planning to put it up inside the bore, you have to remember that you're also going to have to deal with your elbows, your 90-degree elbows coming out of the sides of your rotary joint. But at any rate, once you've done that, it's not hard. I don't think this is accurate. I haven't checked this model, but usually they do have some threaded holes on the fixed portion of the rotary that you can use to make some kind of cross bracket to hold the stationary side of the rotary joint in place so that as the platter spins, the backside remains stationary and your tubes don't get all twisted. But after that, it's kind of all the same stuff we've discussed. You're talking about running a couple air lines up and through the top of the enclosure, which HAAS usually has an opening there already, which probably that's what your cable for this rotary is running through. So zip tie it to that bundle, get your slack figured out, run it to a adapter, a manifold with a regulator, put in a foot switch, take it to the machine control. But this is a very simple process. You can automate one of these HRTs for less than $1,000 in a day if you know what you're doing. And then the TRTs, obviously we talked about the 210, right? This is the magical one that's kind of already set up for automation. And here's what HAAS's 0 point looks like. But any of the other TRTs, so let me pull up, let's go up a size. TRT 310, it is provisioned for air through the trunnion, through the rotary. So you got your aux1, aux2. These are plugs, threaded plugs. So you bring your media in from outside the machine, and then those come out here. So you've kind of already dealt with the B or the A, depending on how you orient this thing, the rotation, because the air is plumbed through the inside. And then you really just have to kind of build your own version of this. It's not complicated. And HAAS has elected to use the rigid copper or steel tubing to hold the stationary side in place. I don't love that, but I'm not enough of a professional about this to really know whether that's a problem or not. Obviously, you're talking about O-rings spinning inside of, polished steel. So I don't see any reason why this wouldn't be strong enough, but I always prefer to have some kind of rigid plate or bar or locking finger in place rather than relying on the rigidity of my copper tubing. But plumbing any of these TRT series is simple. The only product that I'm a little bit leery about, and can I just stop for a second and comment on HAAS's coloring scheme? Because I swear I didn't do this. This is straight off their website, and some engineer straight out of college, went crazy with black and yellow, probably listening to music and orange and red, blue. Who knows? I don't know, man. Anyway, how the struggle here is not the plumbing itself. It's just making sure that you have enough clearance on the backside. I think these larger ones are probably fine. So we're looking at, of course, it's angled. Why can't anything be easy? All right. Yeah. So, and it's metric. Talking couple. All right. Got my units fixed. We're talking maybe 3 inches or just under. So you're going to be hard pressed. Well, it might swing kind of inside of this cast diameter. So you might gain yourself a little more, maybe closer to 4 inches, but you're going to be really tight in there. But if you can overcome the space constraint, either by putting your rotary joint up inside the hole or just by keeping all your plumbing really tight, maybe zip tying or using magnets to really kind of keep your plumbing up out of the way, you could really apply the same logic that you used on the TRT series. I guess the only real drawback here is that these do not appear to have any kind of aux lines on the side. I haven't gone too deep with these TR series, so I couldn't guarantee that's not the case, but yeah, I don't see any kind of air lines, any kind of labeled aux ports, indicating that there's air already through this trunnion. But regardless, if you've got a rotary, it can probably be automated fairly easily without breaking the bank, and that really makes this product way more valuable, especially if you want to fully automate down the road and M code integrate and plug a robot in and all that good stuff. But that's HAAS. That's all I really wanted to talk about today, guys. I hope this is helpful. If you want to integrate, I highly encourage you to go for it. It's really not that bad. I know a lot of companies are intimidated by the idea of really tearing into their machines, but the truth is that most machines are very forgiving. You can get away with doing more than you think you can, and just a little bit of automation on your shop floor will make your life a lot easier. If you like these videos and you want to hear more, please subscribe. If you're interested in our products, please go to our website in the description below and follow us for upcoming product releases. Our Shunk pallets are already live, so if you're running Shunk Vero S, check those out. It's definitely a benefit to your shop to have those available. Thanks, guys.